All around the world today are examples of complex and useful technology, from the phone in your pocket to the internet that allows you to watch this video. The problem, however, is that many of the processes we use today are wasteful, inefficient, and pollute the environment. More and more scientists and engineers are looking to nature as a model for cheap, effective, and eco-friendly processes. Today, I'd like to explain this process through Kranium bicycle helmets. So come, take my hand, and we'll start our journey with Step 1. How bioinspiration begins. Inspiration can be sparked in many ways. We might see a natural process and be curious why it works the way it does. Maybe there's a gap in current technology and we want to find a solution. However, sometimes life just throws us a curveball that will cause that magical eureka moment. Such was the case for Aniruddha Surabi, who was a master's student in design at the Royal College of Art in London when he had a biking accident. Not only did his helmet break, he also got a concussion and had to be treated at a hospital. A concussion is a relatively common brain injury caused when our head receives a direct and sudden blow which can jolt the brain. This can cause bruising, damage to blood vessels, and injury to nerves. According to the CDC, between 2001 and 2009, approximately 173,285 people were treated for concussions from recreational activities. This incident led Surabi to make designing a better bicycle helmet his final solo project for his degree, for which he turned to the humble woodpecker for inspiration. Step 2. Looking to nature for solutions. The woodpecker is known for its ability to peck trees over and over again with no apparent injury to its skull. They can drum 18 to 22 times per second and 12,000 times per day. This is allowed by a special bone called the hyoid bone, which is a Y-shaped bone that encircles the woodpecker's skull. This bone allows the woodpecker's brain to remain in place even as it pecks away. However, what Surabi noticed was the area between the woodpecker's skull and beak, which are connected for most birds. Woodpeckers instead have a soft, cushiony cartilage, which helps ease the blow from the repeated head banging. This observation was the key in Surabi's development of his new line of helmet, the Kranium helmet. However, before we jump into the research process behind designing the helmet, I would like to point out that discovering a novel technology is not limited to master's students or scientists. Even a college student like myself can walk outside and find inspiration from the nature around us. For example, consider walking around your school's quad or the local park and observing the structure and design of the plants and animals around you. Why are they that way? Could this be applied to technology today? Step 3. Research. The next step for Surabi was to apply what he had seen to his helmet design. The first step was to add a new layer inside the helmet to mimic the cushiony layer of cartilage in the woodpecker's skull. Surabi experimented with over 150 different materials, including glass, rubber, and cork, before he found one that felt just right: cardboard. The cardboard he chose wasn't standard cardboard, opting instead to design a special dual-density cardboard. One issue he encountered choosing a material was that the cartilage material in woodpecker skulls was full of non-uniform air pockets that made it hard for a machine to mass reproduce. Thus, instead of being locked into nature's design, Surabi chose to use a hexagonal honeycomb structure that is both strong and easy for a machine to make. This goes to show that when we design a bio-inspired product, it is not necessary to follow nature's blueprint to the atom. Nature designs based on a good enough principle, not an optimal one. Thus, we can and should try to improve our design if we see an opportunity. Back to the story. Surabi then cut out a number of cardboard pieces out of his special material and arranged them in a grid lattice. In the incident of a crash, each cell in the lattice would absorb the impact by bending and collapsing. Now you may be asking yourself, how does this new cardboard helmet design stack up to current bicycle helmets? It turns out that they are 3 times stronger and 15% lighter than conventional polystyrene bicycle helmets. Not only that, but since his helmet is made out of cardboard instead of non-biodegradable polystyrene, it is eco-friendly as well. Now that's a win everyone can be happy about. Step 4. Profit. Surabi has put his new helmet on the market and has even received requests from Force India, a Formula One crew, to design helmets for them. Success! Now let's go through a quick recap of the process he had to go through. First, Surabi found a problem and wanted to do something about it. Second, Surabi was inspired by something he saw in nature. Third, Surabi created a design based off what he saw, but not necessarily following it to the dot. Fourth, Surabi put a successful product on the market. For other examples of this simple process, look up Lotus-on paint, shark skin inspired Speedos, or Velcro, which was inspired by burdock burrs. Of course, we can't expect everyone to do what Surabi was able to do. There are some roadblocks in bioinspiration. For example, some people will look at copying nature as some green holy grail. The reality is that products are mainly made by businesses, not scientists. In order to create eco-friendly and sustainable products, we need to be able to act as both scientists and businessmen. Also, it may not be obvious, but creating a bio-inspired product involves a lot of research. Surabi, for example, experimented with over 150 materials. Frank Fish, who created whale fin-inspired fans as the president of Whale Power Corporation, had to spend a lot of time in research, ultimately publishing multiple papers before he began his business. Despite all these warnings, however, I'd like to point out that in the end, Surabi was not getting his master's degree in bioengineering or working on a PhD in bicycle design. He was just an average person who was inspired by something he saw in nature and took the necessary steps to develop it. If we have the proper mindset to look out for cool things in nature, and the time and work ethic to back it up, then that could be us as well. Be on the lookout.